So today I think I will finish chapter 16. I don't have much more left, and that will end the material for the exam. So let's go ahead and finish up this chapter. Okay, let's first do some housekeeping items for today. Right, so today is the 26th of October. There's no lab today, so I have dropped a lab for this week. So you can have that personal time to catch up on your work. So as far as lab reports are concerned, there's the acid-base problem set. Okay, so turn that in today, and I'll give you the 100 points as long as everything looks okay with me. The lab report on spontaneity will be due next Wednesday. Spontaneity. So that will be due next Wednesday, and next Wednesday I will not have a lab, so you can use that time for your exam. So let's talk about next Wednesday here. Next Wednesday there'll be no lab because that will be your test date. Okay, the following week we'll have the lab, so not next Wednesday. Next Wednesday will be the final lab. So no lab. But the lab report on spontaneity is due. And there'll be test 3. Okay, so what I will do is have a review Friday and Monday. So part 1 on Friday, part 2 on Monday. So test 3, multiple choice and written. And the way my system works is the quiz is due on the same day as the exam. So quiz 3 will be due next Wednesday. And homework 16, as I finish this chapter, let's make that due. Today's Wednesday, Friday, Saturday. Let's make that due on Saturday. Okay. You can turn it in Sunday, that's fine. It's not that I'm going to look at it over the weekend. So, what is Sunday? The 30th. So, turn that in on Sunday for 10 points. Your test will cover chapter 15 and 16. So we'll have a review on Friday and Monday with regards to that. So that is this week and next week. Are there any questions on this? The homework 16 is where you should be on. The acid-base problem set should be turned in. Your lab report on spontaneity should be turned in next Wednesday. And next Wednesday I'll also give you another day for no lab. You can use that time to do your test. Also, next Wednesday we will have class. Okay, so I'm going to continue to lecture next Wednesday. Everyone okay with that? Well, even if you're not okay, I'll still lecture next Wednesday. Okay. I know some of you are disappointed that you have to lecture at all. All right. Any questions? Questions or comments? Okay, yes? No? All right, let's finish up this chapter now. Okay, so what are we talking about here? So we're talking about KSP. Okay, this is the wrap up for this chapter. KSP is called the solubility product constant. Okay, so it will be a solid that's in an equilibrium with its ions. As an example, maybe think of anything that's sparingly soluble. A sparingly soluble solid. Okay, there's a whole bunch of sparingly soluble solids. Here's one of them off the top of my head. Okay, barium sulfate is a solid. We used to have some barium sulfate here actually, but it looks like we don't have any barium sulfate. So it's a solid. It's a white solid, and it's in an equilibrium. Okay, with Ba plus 2 and SO4 minus 2. Right, so here's an example of a sparingly soluble solid that has a KSP. Okay, this is products over reactants. Because this is a solid, we do nothing with it. Okay, because this is a solid, we don't do anything with it, so the KSP is going to be Ba plus 2 concentration times SO4 minus 2 concentration, products over reactants. All right, and when we do our ice table for this, okay, remember in an equilibrium, okay, remember in an equilibrium, okay, we're looking at the back and forth arrows. Okay, for an equilibrium, it's a back and forth. So this means ice table, but because it's KSP and it's a solid, also look at this solid, right? This is a solid. Because it's a sparingly soluble solid, we'll go plus S, plus S. All right, so that is a review of what we've been talking about this last couple of weeks. What we left off with on Monday, the last part of this chapter, has to do with the common ion. Okay, so what I want you to recognize about the common ion is that it suppresses ionization. So it's a good multiple choice question. Okay, it suppresses ionization. So if you have a common ion, whether it's a barium ion or sulfate ion, let's say I have barium nitrate, which is BaNO3 2, okay, barium nitrate. Okay, we learned in Chem 1 that all nitrates are soluble, so really barium nitrate is barium ion and nitrate ion. So because of this, we have a common ion, okay, barium ion. Here, the reaction will go this way, away from the ions. Okay, so if we add some barium nitrate, all nitrates are soluble. Okay, the common ion here is barium ion, Ba plus 2. So common ion effect, I want you to know it suppresses ionization. Okay, it's going to move it towards the solid. Okay, so this is with the common ion effect. Right, so here's a common ion effect problem, example 10. It involves calculating the solubility of AgCl in grams over liters in a 6.5 times 10 to the minus 3 molar solution of silver nitrate. Okay, so let's go ahead and do this problem here together. Okay, that will be the last of this. let me just get my book out here. So AgCl, solubility, this is S. Okay, AgCl is a solid, and that solid is in an equilibrium with Ag plus aqueous. Okay, plus Cl minus aqueous. All right, the KSP for this is, hold on, I'll tell you that. And I'll tell you that on the exam. The KSP for this is 1.6 times 10 to the minus 10. Okay? A very small number. Okay, a very, very small number, which means the reaction predominantly favors the left-hand side if it's a very small number such as this. Okay? 1.6 times 10 to the minus 10. All right, so we're not calculating it in water. Okay, we're calculating this in the solvent that's not water. We're calculating this in a solvent that is 6.5 times 10 to the minus 3 silver nitrate solution. So we can do the same thing. Remember, all nitrates are soluble, so the silver nitrate is going to be Ag plus ion and NO3 minus ion. NO3 minus is called the nitrate ion. Nitrate is NO3 minus. All right, so some of it's going to go this way. Okay, so this will be plus S. And then there's another source of Ag plus. Okay, what's the other source of Ag plus silver? Okay, the other source of the Ag plus is 6.5 times 10 to the minus 3. So not only is this plus S, but it's also going to be 0.0065. Okay, you see where I'm getting this? Okay. So there's two sources of Ag plus. One is the reaction going this way. Okay, that's KSP, which is 1.6 times 10 to the minus 10 worth. And the other source of Ag plus is this. So the silver is the common ion here. Okay, so let me box it in blue. That's the common ion. Silver plus coming from the reaction going backward, silver plus coming from the solvent. In this case, the solvent is silver nitrate. All right, so this is what I want you to do on the exam. Okay, and then plus S here. Okay, Cl minus. All right, let's go ahead and put this into our KSP expression. KSP is products over reactants. Okay, we will not do anything with the solids. So products Ag plus over reactants. Okay, so Ag plus is S plus 0.0065. Cl minus is S, which equals KSP. I'll give you KSP. I looked it up. It's 1.6 times 10 to the minus 10. Here we will do a low ionization assumption. So we will assume S is small. Okay, so if S is small, S plus 0.0065 is about 0.0065. Okay. See, 1.6 times 10 to the minus 10, this constant is very small. So very little S is going this way. It's such a small number. It's a very small number. So very little is going this way. Most of the Ag plus comes from the silver nitrate. Okay? Everyone see this? This is a very small number, so the equilibrium favors this. Very little goes this way. Most of the Ag plus is coming from silver nitrate. So while assuming S is small, this makes our math just a little bit easier. So 1.6 times 10 to the minus 10 equals 0.0065 times S. Okay, we will solve for solubility S. So here S is solubility. Okay, here S is solid, okay? Sparingly soluble solid. So 1.6 times 10 to the minus 10 divided by 0.0065 gives us S. And in my calculator, I am getting, you can check my math here. Here the units are big M. So on the exam, okay, I want the right units for solubility, and that's moles over liter, big M. So this is 2.1 times 10 to the minus 8, big M. Okay, that's the solubility. Right, so the solubility of Ag plus is S plus 0.0065. So the solubility of that is 2.41 times 10 to the minus 8 plus 0.0065. Okay, this is pretty much 0.0065. Okay, taking a very, very small number and adding it to 0.0065 is still going to be 0.0065. Okay, it's a very, very small number, which tells us that most of the Ag plus soluble is coming from AgNO3. Okay, most of the Ag plus soluble is coming from AgNO3. Okay, which has a concentration of 0.0065 big M. Okay, this is the solubility coming from AgCl KSP going this way, which is very, very small. Going to the right, right? All right, one final thing here. They're asking for it in grams over liter. Sorry. Okay, one more thing here. They're asking for this in grams over liter. So let's go ahead and put this in grams over liter. So in grams over liter, this will be... Oh, well, first of all, sorry, I'm so sorry. The solubility of Cl minus is going to be S, and that's going to be 2.41 times 10 to the minus 8 big M. Okay? And here the S stands for solubility. Okay, putting this in grams over liter, we'll put the 2.41 times 10 to the minus 8. Okay, moles over liter of AgCl, and 1 mole of AgCl has about 143.232 grams of AgCl. 143.32 grams. Okay, the moles cancel. And what's 2.41 times 10 to the minus 8 times 143.32? About... about 3.45 times 10 to 3.5 times 10 to the minus 6 grams over liter. Okay. On the exam, I will probably have you just put it in molarity. I won't have you do grams over liter stuff. Okay, but if it's if I ask you grams over liter, you just multiply by the molecular weight. Okay, that's all. Okay, so if I ask you grams over liter, multiply by the molar mass. All right, so something like this will be on the exam. Okay, we're looking at the common ion effect. All right, this is our last section here that I'm going to go over, and then that will end chapter 16. Okay, so let's go to page 18. Are we okay? Go to page 18. Okay, I will not cover from here on down. Okay, I will not cover this. Okay, this is complex ion formation, and it's something I will not cover. But I will cover this part, and that will end the class and end the chapter. All right, pH and solubility. Okay, so let's look at this with me here. So let's just take this as an example. Magnesium hydroxide. Okay. Let me rewrite this. Magnesium hydroxide is a sparingly soluble solid. That's an S there. Which is at an equilibrium with Mg plus 2 plus OH minus. And this has a KSP very small of 1.2 times 10 to the minus 11. All right. Now, okay, we studied pH in chapter 15. I just rewrote that. We studied pH in chapter 15. Okay, pH is the power of the hydrogen ion concentration, right? POH is the power of the OH minus concentration. POH, how basic it is. pH, how acidic it is. So we'll take the sparingly soluble solid, magnesium hydroxide, and what will we do? Okay, let's say we add acid to this. Okay. To this sparingly soluble solid. So what will the acid do? Okay, the acid is going to react with the OH minus. The acid will react with the OH minus, and it will give you water. Okay, acids will neutralize the base and give you water. You add acid, H+, okay? It will react with the OH minus, giving you water. So how will this affect the equilibrium? Okay, the acid will remove the base, so we remove OH minus. So according to Le Chatelier's principle, which way will the reaction shift? Okay, it will shift right or left. Okay, we're removing OH minus here. Okay, if you remove OH minus, the reaction will shift this way to counteract the OH minus being removed, correct? So the acid reacts with the base, removes the OH minus, the equilibrium shifts that way. This is Le Chatelier's principle. So the equilibrium is going to shift to the right. Which means that you will dissolve this solid. You will dissolve this sparingly soluble solid. So acid, H+, will dissolve this. Okay, remember, acids are a source of H+. Okay, let's say we add OH to this. Okay, so here, scenario 1, I'm adding acid. Okay, in scenario 2, I'm adding base, OH minus. Okay, so what's going to happen? Okay, the OH minus, so this is scenario 2. Okay, added on to the OH minus here will shift the equilibrium to the left. Do we see that? Okay, according to Le Chatelier's principle, we add more OH minus. The reaction will shift to the side to remove OH minus. In this case, that will be to the left. So this reaction, by adding base to this, it's going to shift left. Meaning adding a base, such as sodium hydroxide or calcium hydroxide, adding a base will actually cause more precipitation. Adding a base will cause more solid formation. Okay, everyone see this? Meaning a base will cause more magnesium hydroxide production. So let's say we want to dissolve magnesium hydroxide for whatever reason. Okay, what can we do? Okay, we can lower the pH. Okay, make it more acidic. Let's say we want to make more magnesium hydroxide. Maybe you're in a factory and they need to make magnesium hydroxide in the company. What will you do? You will increase the pH because that will give you more solid. Okay, if you're in a factory that's making magnesium hydroxide, I actually think they use it in the food industry. I may be wrong, like caking or whatever preservatives or whatever they put in these boxed foods. Okay, they'll use some magnesium hydroxide or calcium hydroxide. So let's say you work in some company, okay, that's making some preservative to preserve the food. You want to make more magnesium hydroxide, raise the pH. Okay, let's say you want to dissolve the solid because you don't want it in your whatever reaction. You lower the pH. Okay, there you go. So definitely there's an effect of pH on whether something will stay in solution, that is stay dissolved, or whether it will be a solid and precipitate. You can mess around with the pH, and you can mess around with a solid that will dissolve, or a solid that will precipitate, make more solid. Okay, so we will skip 18, 19, and 20. That involves complex ion formation, so I've decided not to cover that in this class. So 18, 19, and 20, you can go ahead and not worry about it. Also, on your homework set, you don't have to, your acid-base set, you don't have to worry about that. Okay, so I think I told you to skip those problems. All right, so on Friday, we will review day 1, then Monday we'll review day 2, and then Wednesday we'll start chapter 17, okay, the last 2 chapters.